Welcome, Hornets, and thank you for joining me today. Today we're looking at assignment number 6 from AP Calculus AB. This is coming from chapter 5.7, and we're looking at the natural logarithmic function and how we utilize it in order to find our integrations, whether they be definite or indefinite. So we're going to be taking a look starting on page 354. We're starting at number 1. We're going to be cruising through the odd problems. So if you haven't tried to do them already, I do recommend that you do that. Otherwise, this is probably just me doing the homework for you. Now, if you're getting stuck, that's a different thing. Alrighty, so here we have our first problem, the integration of 5 divided by x, natural log of x. And what you want to do is bring that 5 out, so you have 1 over x dx. We now know this is our natural log of x, and we can now put it in front, and don't forget your plus c. Number 3 is asking us to now work with 1 over x plus 1 dx. And in this, we can think about it as a u-substitution. Please be aware if you do, you're letting u equal the x plus 1, then your du is equal to dx, and you're just looking at 1 over u du, and we end up getting the natural log of u plus c, and we back substitute to get the natural log of x plus 1 plus c. Now you'll notice we could go directly there. However, I do want you to be very careful because if we have things like 1 over 1 minus x dx, this comes out as the negative natural log of x, 1 minus x, plus c, and that's for the same reason of our u sub. We'll end up getting a negative dx, brings the negative out in front, that'll pull the negative out, and then we take our natural log normally. Alrighty, let's go ahead and continue. This brings us to number 5. Number 5 is working with 1 over 2. We have x plus 5 dx. Notice that 2 right there. Same thing if we use the u substitution, 2x plus 5. Du becomes 1/2 du equals the dx. And we now have 1/2 the integration, 1 over u du, and this gives me 1/2 natural log, back substitute. And so what one can now say is that if you have a coefficient in front, that's going to come out as the reciprocal of. Okay, let's go ahead and take a look at, that was number 5. We're now looking at number 7. Number 7 gives us the integration of x. We have x squared minus 3 dx. Once again, we're using that u substitution here so that we have x squared minus 3 du equals the 2x dx, and this gives us 1/2 du equals the x dx. We can now back substitute here, giving us this 1/2 x dx is the du, and our u on the bottom. This is 1/2 then the natural log of x squared minus 3 plus c. Let's continue. We're going to number 9 next. Number 9, we have the integration. We have 4x cubed. We have a plus 3. We also have x to the 4th plus 3x dx. Once again, I'm going to use a u substitution first, see what I get when I take x to the 4th plus 3x. Do I get that numerator? Well, du equals 4x cubed plus 3 dx, and I would have to say yes. So 1 over u du, and when I go through, I end up having the natural log of the absolute value of x to the 4th plus 3x plus c. And that's number 9. Number 11, we're taking a look at the integration. we have x squared minus 4 over x dx. Now you'll notice in this problem, our numerator is larger than our denominator, so I'm going to first start by separating it so that I have x squared over x minus 4 over x dx. This can now simplify, or I could do long division if you so choose, but that seems like a little bit of a heavy-handed use since we can go directly to it. We're now going to integrate each piece one at a time. Think about it like this. I think this is an easier way to kind of see it. It's up to you, however. You can go directly from it and get yourself that 1/2 x squared minus 4 natural log of the absolute value of x plus c. Don't forget that absolute value. Let's take a look at number 13 as we continue on. Number 13 is now giving me the integration. I have x squared plus 2x plus 3. I have x cubed plus 3x squared plus 9x dx. Now when you see these, don't be afraid of them. Just go directly into it. Take that u, make it the denominator, x cubed plus 3x squared plus 9x. Now take the derivative. Du is 3x squared plus 3 times 2x plus 3 times 3. Now, the reason why I wrote this in factored form is so that you can see that we have that x squared, we have a 2x, and we have a 3. And what we have to do is remove the 3 that's in front, giving us 1/3 du, x squared plus 2x plus 3, and then I can't forget my dx all the way in the back. Now we can clearly see that we have 1/3 1 over u du, and this is giving me 1/3 the natural log of u, and I have that x cubed plus 3x squared plus 9x, the quantity plus c. Notice how they go quite cleanly. You just have to jump into it, don't be afraid of it, and you'll be okay. Let's go ahead and take a look at number 17 next. Number 17, we're looking at the integration. We have x cubed minus 3x squared plus 5, and I have this x minus, and that's what, x minus 3 dx. Alrighty. Oh boy. Well, I see no other option but for us to do long division here. So that's where we're going to start. We're going to take that x minus 3 and we're going to divide it into x cubed minus 3x squared. I'm going to put in the placekeeper of a 0x plus 5. Shouldn't take us too much. We have x cubed divided by x gives us x squared. So we're looking at x cubed minus 3x squared. We're subtracting, and you'll notice we're left with just plus 5. So we have plus 5 over x minus 3. And that's now what we're integrating. All right. Now as we integrate, we have our 1/3 x cubed. The 5 comes out in front. We have the natural log of x minus 3 plus c. And there is our answer. Number 19. Now we're just continuing with this all the way through. Once again, there's really not much here except problem after problem of practice. And I would expect that you just keep going, try them. I know that you're going to get tired of them. I know that it's tedious, but it's to your advantage to get used to it. And if you don't, then, you got a problem when you move on. This is what we do in calculus in college. All right? You do the work. You don't balk at it. You just do it. I know it's kind of silly, but it is the truth. So I have x to the fourth plus 2x cubed. I'm subtracting a negative 2x cubed plus the 0x squared plus x minus 4. Doing it again, negative 2x cubed divided by the x, negative 2x squared minus 2x squared minus 2x cubed minus 4x squared. I'm subtracting 4x squared plus x minus 4. Continuing, we now have 4x squared divided by x. We're looking at 4x plus the 4x, distributing 4x squared plus 8x, and we're subtracting. This is giving us minus 7x minus 4. Minus 7x divided by x gives me minus 7. Minus 7 is giving me minus 7x minus 14. We're subtracting, and I'm left with 10. So I have plus 10 over x plus 2. Whew! All right. Now the integration of this is easy. Keep in mind that this now is 1/4. X to the fourth minus 2/3 x cubed plus, this is now 2x squared minus 7x plus 10 natural log x plus 2 plus c. There it is. Just straightforward. Once again, don't let these problems get to you. They're not worth it. All right? Okay, here we go. We're going to take a look at number 21. Then we're going to take a look at number 23. And we're going to then stop this video. I'll then finish some more in part B. So let's take a look at 21, maybe up to 25. After all, that is the first section. They give us the natural log. We have the natural log of x squared. Oh my goodness me, look at that. Well, gee, what are we going to do when we look at this problem? Well, I'm going to let u equal that inside piece, the natural log of x. We know du is 1 over x dx, and there I see it. It's simply u squared du. And I can now go 1/3 natural log of x. Please be aware, I'm going to put parentheses cubed plus c, and that's my answer. All righty, we've got ambulance going by. Gotta love that. Let's go ahead and continue. Now we're looking at the integration of 1 over, and I've got the square root of x. We have 1 minus 3 natural log of x dx. Alrighty, once again, I've been telling you, don't be afraid of it, so let u equal 1 minus 3 natural log of x. Du is then going to equal negative 3 over 2 root x dx. Oh my goodness me, look at that. We're pretty darn close, but we do not have that coefficient. So negative 2/3 du is going to now equal the 1 over root x dx, and now I can put it together as negative 2/3, and I have 1 over u du. Negative 2/3 natural log of my u, 1 minus 3 root x, plus c. And oh my goodness me, we've got number 23. This leads us to number 25. 25. 25 gives us a 2x on top. We have this x minus 1, the quantity squared. We have a dx. All righty. Well, you know, I'm just going to have to say I think that there's probably a way in which I can do this. Let's take a look if I let u equal x minus 1, I know that du is equal to the dx, but I also know that x is equal to u minus 1. So that's what I'm going to try and do. I'm going to change this so that I now have a 2 and a u minus 1. I know I have du back here, and I know I have a u here. And it's a u squared. Alrighty, let's simplify it. That means that I have u over u squared minus 1 over u squared du. See how it worked out? This is simply 2, the integration 1 over u minus u to the negative second du. Remember to always change that to our power. So here we go. 2 natural log of whatever our u was, x minus 1. And then we have this integration. Adding 1 dividing by the new power is 1 over u, and that's x minus 1 plus c. And there's number 25. And this was the first section of your assignment number 6, and this is the end of part 1. Alrighty, thank you very much for watching this. Please remember, if this is helpful, please remember to hit like so that I know that I'm doing a good job. Thank you very much. Please be well, take care, and I hope to see you for part 2. Be well now, take care, and remember, it's easy to be mean. So please, be nice. Change starts from within, Hornets. Bye-bye, everybody.